Here we have job number 12299, and it's a faulty Bluetooth speaker that has a damaged USB-C charging port. I promise you the speaker doesn't just look like this. There's a lot more to it. But I've taken it out of the chassis, and just here you should be able to see the damage that we have for the USB-C speaker. Now if we go on over to the scope, you can see the damage a bit clearer. You can see here that we have a trace missing. However, it connects to this trace here. So there's no actual need to do a trace repair on this. So it should be a nice straightforward repair. See what we're going to do. Let's start off, get our flux, put some flux on the board. And we're just going to put some leaded solder on to melt the original unleaded away. And then we can use our wick to get rid of it. The soldering iron around here, there we go. And here. Nice. And then just over the pads. Sweet. Now we come in with our wick, get rid of the solder in the ground holes, which we should be able to do fairly easily with leaded solder. A lot of people ask why I don't use low melt solder. Thing is, if being honest, I've personally not tried it. Leaded always seems to kind of do the job for me. I bet it's going to show now that it's not going to do the job for me. Because I mean, it's not. There we go. Might need to end up using the solder socket anyway on these ground legs, which is typical considering I was just speaking about low melt solder. Because the iron doesn't want to seem to go all the way through the board. It's not the thickest board in the world, so I'm failing to understand. There we go, that one was relatively quick and easy. Alright, let's just clean out the pads. Isopropyl alcohol and cotton bud, so we can at least see what's going on. There we go, it's a little bit better. Go ahead and clean out these with our solder sucker. Put our air temperature down because, again, it's quite a thin board and this shouldn't take too long to get these holes clear. We are going to be using the drop method with this USB-C port. I'll show you that in a second. I've just got that little bit over here. I don't know if that's solder, you know. I think that's pad. Where is it? There we go, it's gone now. Okay, sweet. Whilst board's nice and hot, come back in with some flux. Fill up the holes again with leaded solder. And just go over the pads. Get rid of any bridges. There we go. Give it a quick clean with some isopropyl alcohol, as you can see. Now we've got quite a lot of solder in the ground holes, but that's good because that's going to melt, and when it wets, it's going to go through the board and give us really strong anchoring points for our USB-C port. I use this method on pretty much everything. Alright, so we apply a tiny bit of flux just around the area. Let's apply some flux. Now we'll go over all of the joints just to ensure that the solder goes from the pins to the actual board itself. Just make sure we try and clear any bridges that we have. After a brief check with my pokey device, you can clearly see here that some of the pins aren't connected to the board, so I need to go over them and just ensure we have a solid connection. Just had to go over all the pins there, but they are now solid, as you probably just saw. But a little bit of plastic on the back of the port. This is the original port that came off of the board. Again, like I said earlier, this is shared with ground, so the fact that it's bridged here is, if anything, just making it a stronger connection. Let's go give it a test and see if it works. And here we have our little amp/speaker thing, drawing a healthy 0.88 amps. We're working absolutely fine. Thanks for watching, and we'll see you in the next one.